Okay, in this final episode, we're going to try to match the motion or dot diagrams that we might see on ticker tape with the shapes that we see on the graphs. In number 6 here, we're going to work with position time graphs first, and then we'll go from there and look at the velocity graphs. Now, in terms of the position graphs, letter A is starting with a very steep positive slope and then heading toward a very shallow or zero slope. Now on position time graphs, slope equals velocity. So A shows us slowing down, and since those slopes are positive, A is showing us moving to the right. Now to show slowing down, I should start out with a pretty wide gap, and then that gap should gradually close as I move further and further along, and eventually I'll be in the same place the whole time because I'll be at rest. So we should see decreasing spacing between the dots. If we were to also show it as a complete motion map, we would show the velocity vectors, and they would be getting shorter and shorter as we moved until at the end we wouldn't be able to see the velocity vector because it would be 0. In section B, we're starting out with a very flat positive slope, and we're getting a much steeper positive slope. Now it's a positive slope, so we're still moving to the right, but this time it's essentially the reverse. We're going to start out close together, and then we're going to see a increase in the distance between. These dots, again, all occur at the same time, 1 second in between, half a second in between, whatever makes sense with the device we're using. So we're covering more distance here in a period of time, say a second, than we were here. So we're going faster now than we were before. So we have positive velocity and positive acceleration, and therefore we're speeding up. Now C shows us going from flat to steep, but in the negative direction. So that means we're moving to the left instead of to the right. This arrow is just showing that we're trying to match these with the graphs over here. It doesn't tell us anything about the motion of direction of the motion. And it's getting steeper, so as I move toward the left, I need to start again close together, and then with each dot I should get a bigger and bigger spread of distance in between. Getting faster. Now this time I actually have negative velocity and negative acceleration. Here they still match, so negative acceleration means we're getting faster. In D, we're moving in the negative direction. My slopes are negative, so I'm moving this way, but I'm slowing down. So again, I start with broader gaps, and then those gaps start to close up, and I get slower and slower until I reach what looks like rest, or a pretty flat slope at the end. Okay, so that's position time graphs. Now we're going to try the velocity time graphs. Now you got to make the leap. Remind yourself that we're not looking at the position or location of the object, but how fast we're moving. If it trends toward 0 line, that means it's slowing down. If it trends away from the 0 line, that means it's faster. If it's below 0, that means it's negative direction. If it's above 0, that means it's in the positive direction. So A is starting at 0 and rising away from 0, so it's getting faster. It's doing that all above 0, so it's moving in the positive direction, and it's going to be getting faster and faster and faster. B is again all above the 0, so it's in the positive direction to the right, but it's slowing down. So it starts broader, wider gaps, and those gaps close until we slow down and stop. We do stop, in fact, because we are at 0 for B. C, we're not quite at 0, it looks like at the end, but we start with a larger negative number and trend towards 0. So this time we're moving to the left because we're heading toward, we're in negative direction, we're moving in the negative direction. And we are slowing down, so we start with larger and then as we move, we get closer and closer together until we reach a point at which we stop. And finally, D, again, we are moving in the negative direction the whole time. We're always below 0. There's no change of direction on any of these. None of these go through 0. And we have the moving away from 0, which means our number, our magnitude is increasing. Our size is increasing. So we're getting faster. So we start close together, and then with each maneuver, we're going to get larger and larger and larger. Okay, so the two different graphs show us if we're speeding up or slowing down in different ways. In position time graphs, you want to look for the slope and the change of the slope, because that's your velocity. So as it curves, we're going to either speed up or slow down. If the curves become more shallow, we're slowing down. If they become more steep, we are speeding up. With velocity graphs, it's going to be the trend away or toward 0. Away from 0 means the number is getting larger, means the magnitude of the velocity, the speed is getting larger. If it trends toward 0, then the number, the magnitude of the velocity, known as speed, is getting smaller, so we're slowing down. Direction is shown simply by whether you're above or below 0. Above 0 would be the positive direction, below 0 would be the negative direction. And that's how we can match up the different types of motion. If we had these pictures drawn for us, we should be able to sketch general shapes for the velocity and position time graphs from those types of diagrams.